Hi, I'm going to explain definition of a limit. I'm first going to give it to you. It says the limit as x approaches c, some number, of some function f of x is equal to this limit that I'm going to call L. And this limit means that for each epsilon, and epsilon looks like an E, epsilon greater than 0, there exists, sorry about that, exists a delta, and delta is kind of a fancy D, greater than 0, such that if zero is less than the absolute value of x minus c is less than delta, then the absolute value of f of x minus the limit is less than epsilon. All right, what does that mean? Well, let me show you a little picture here. First of all, I'm going to have some type of function. I'm going to draw a function that looks like this. I'm going to call that f of x. And right here is my c. All right. So as I approach c from the left, I'm at a position over here to the left of c. This distance between this spot and c. Now remember, I'm not going to c because sometimes c doesn't exist on f of x. But I'm at a value that I'm approaching c from the left. The distance that value is from c, I'm going to give a name. And I'm going to call this distance right here delta. All right? And so this value, since this is c right here, I can say that this value is c minus delta. All right? Now, I could be approaching c from the right. Well, this distance from the right, I will also call delta, whether I'm approaching the left or the right. So this part right here is c plus delta. And they're going to have values on f of x. So I'm going to draw a line here. Now, I have a value right here that is L. Okay? Well, as I approach from the left to c, and I'm at the c minus delta, I'm going to be on my graph a little bit below L. And it has a distance from this spot to L, and I'm going to call this distance epsilon. So this is L minus epsilon. Over here, if I'd have c plus delta, I'd be a little bit above L. Again, this distance that it's above, I'm going to call epsilon, and this would be L plus epsilon. All right? So if I take a look at this, I have an f of x value, and I have an L. If I wrote f of x minus L that would be the same, that this distance right here, that's going to give me this, another name for f of x is L plus epsilon. My epsilon's kind of goofy. So I could write L plus epsilon here. And I'm going to get my epsilon value. And over here, if I did the same type of thing, I could have L minus epsilon minus L, and I would get a negative epsilon. But since I'm talking about distance, I'm going to take the absolute values of those. So in both cases, I get epsilon. Now, I could have an f of x here and f of x here. Well, I'd be within that epsilon. So what I say is the absolute value of f of x minus L is less than some epsilon. Now what does that epsilon mean? Some arbitrary value. Some value that's extremely small that I'm going to be within here to be close to this limit, to close to this L. Now I could do the same thing down here, in that this is an x value and this is an x value. So if I take x minus c, well, I could call x minus c plus delta minus c, and I would get delta. Or I could take c minus delta, if I'm to the left, minus c, and I'd get a negative delta. But since I'm talking about distance, I'm really talking about the absolute values of those. So I get that. And what I'm trying to show is when I'm within a certain epsilon here, I'm within a certain delta over here. And there's a relationship. So over here I'm going to have the absolute value of x minus c is less than delta. And so I'm going to establish in this formal definition that says as I get closer and closer to L here, in other words, my epsilon keeps getting smaller and smaller, my delta keeps getting smaller and smaller. There's some type of relationship between the two. And so we're going to look at a series of problems. I probably got 2 to 3 more videos explaining this concept of epsilon delta. And this is just kind of the beginning of this discussion. In the next video you'll see, I'll give you some type of application in which we experience this relationship between delta and epsilon.